Welcome everyone. Today I will discuss circular permutation. Now this part is not included in West Bengal Board of Secondary Education as well as in CBSE also. But this part is most important part of permutation. So we have already considered linear permutation. By permutation, we always mean linear permutation. So what is linear permutation? You know, if things are arranged along a straight line or along a row, then this type of permutation is called linear permutation. In case of linear permutation, look, there are two endpoints. And you know, linear permutation of n things, linear permutation of n things equals to factorial n. So it is already known to us. Now what is circular permutation? So look, in this case there are two endpoints. So when the things are arranged along the circumference of circle, then this type of permutation is called circular permutation. Look here, things are arranged along the circumference. A, B, C, D, four things. They are arranged along the circumference. So look, one is anti-clockwise. And look, it is in case 2, it is in clockwise. A, B, C, D are arranged in clockwise. This is figure 1, figure 2. So in case of circular permutation, there are no endpoint. There are no endpoint. So circular permutation of n things equals to factorial n minus 1. Here we fixed any point, then we arrange the remaining n minus 1. So circular permutation of n things, factorial n minus 1. Now suppose this is a round table and 4 persons A, B, C, D are arranged in a dinner party. So A, B, C, D, and or they may sit in this way, in clockwise or anti-clockwise direction. So look, but in case of forming garlands, necklace. Suppose there are 4 flowers of different color. So we can form a garlands in clockwise direction and anti-clockwise direction. If we turn off the garlands, then we see that the figure 1 and figure 2 will be same if we reverse it. Similarly, in case of necklace, so suppose there are 4 beads A, B, C, D. So you are getting a necklace having 4 beads. And here also you are getting a necklace in clockwise direction. Now if you turn off or reverse the garland, you get same A, B, C, D in same order. If you reverse it, so anti-clockwise and clockwise direction will be same. So in this case, circular permutations of n things when there is no distinction. When there is no distinction of clockwise and anti-clockwise direction equals to half of factorial n minus 1. So these are the case of forming beads and garlands. In this case, clockwise and anti-clockwise directions will be same. So this is our working tool. Now, linear permutation of n things. Linear permutation of n things taking r at a time equals to NPR. So this is a result of linear permutation. Similarly, circular permutations of n things taking r at a time equals to NPR by R. And when there is no distinction in clockwise and anti-clockwise direction, then it is NPR by 2R. So, no distinction in clockwise and anti-clockwise direction, then this one. So this is the only difference. So this theory you have to keep in mind. So linear permutation, there are two endpoints. Linear permutation of n things taking all at a time, factorial n. N things taking r at a time, NPR. Now, when things are arranged along the circumference of circle, then it is circular permutation. Circular permutation of n things, factorial n minus 1. Circular permutation of n things when there is no distinction between clockwise and anti-clockwise direction, half of factorial n minus 1. And circular permutation of n things taking r at a time, NPR by r. And when there is no distinction of clockwise and anti-clockwise, NPR by 2r in case of forming bead or garlands. Now, let us verify the result. If r equals to n, this is NPN by n. R equals to n. So, r equals to n. NPN by n. So, factorial n by n equals to factorial n minus 1. So, this is general result. So, this is the theory. Now, we solve some problems of circular permutation. Now, we consider two problems, same type. Problem number 1. Find number of ways in which 8 different beads can be strung to form necklace. 8 different beads. So, I have already stated, in case of forming garlands, necklace, there is no distinction between clockwise and anti-clockwise direction. So, problem 1, so number of beads. So, number of circular permutation. Circular permutation of 8 different beads. Different beads equals to, what is our formula? Factorial n minus 1. So, into half. So, half of factorial 7. So, 5040 by 2. So, 2520. So, this is 1 marks problem. 1 mark problem only. So, in case of forming bead necklace, so there is no distinction of clockwise and anti-clockwise direction. Now, problem number 2. This is restriction is given to this problem. Find the number of ways in which 8 beads of different color can be strung to form necklace, so that 4 particular beads are never separated. So, we have solved this type of problem in linear permutation. So, 4 particular beads, we consider 4 particular beads as a single entity. Suppose B1, B2, B3, B4, they are not separated. So, we consider them as a single one. So, considering 4 particular beads as single entity, as single one, we have 1 plus 4 equals to 5 beads. So, these 5 beads can be arranged in a circle in half of factorial 5 minus 1. So, half of factorial 4 ways, that is 12 ways. 5, so 5 minus 1, 4, and there is no distinction of clockwise and anti-clockwise direction. Now, 4 beads, look, they can change their places. So, 4 beads can arrange in factorial 4 ways. This is not factorial 4 minus 1 by 2. This is 4. This is actually linear. There 1, 2, 3, 4. 4. There is no end point. This is a segment in factorial 4 ways. Therefore, by APC, total number of possible ways 12 into factorial 4. So, 12 into 24. This one. So, 1 and 2. They are of same type. Now, we consider 2 similar like problem. in 5 boys and 5 girls sit alternatively around a round table, in how many ways can this be done? Can this be done? So, alternatively. So, I have already solved this type of problem in linear permutation. 5 boys, B1, B2, B3, B4, B5. And how many gaps? 1, 2, 3, 4, 5. If we put girls to these gaps, then they are in alternative positions. So in case of linear permutation, you know, if there are 5 boys, then there are 6 gaps. But here only 5 gaps. So first one, 5 boys can be arranged in a circle in half in factorial n minus 1 ways equals to factorial 4 ways. Factorial 4 ways. Now 5 girls. Now putting boys here in factorial 4 ways. Now 5 girls. So there are 5 gaps. 5 gaps. There are 5 gaps. If we place 5 girls in 5 gaps, then no 2 girls, then boys and girls, this is our conditions, are in alternative. If we place 5 girls in 5 gaps, then boys and girls are alternative. So this can be done in 5p5 ways. So 5 gaps, so not in circular here, in 5p5, that is factorial 5 ways. 5 gaps and 5 number, 5p5. So by 8pc, number of possible ways equals to factorial 4 into factorial 5. So 24 into 1 to 0. 1 to 0. This is our final answer. So look, 5 boys can be arranged in a circle in factorial 4 ways. Now, boys are arranged along a circle. Then there are 5 gaps. You have to place 5 girls in 5 gaps. And this can be done in 5p5. So, in gap we are placing the girls. Do not consider that this is in circular permutation. It is of linear permutation. We are getting a string and in the gap we are placing the girls. So mind it is not in circular permutation. Now second one, there is a restriction. You look for the second problem. In how many ways 15 members of a council sit along a round table when secretary and assistant secretary sit on two sides of president. Total member 15, but there is a restriction. Secretary and assistant secretary. This is secretary and this is assistant secretary. This is president. So, this is 3. So, they are together, but president is at the middle. There is a restriction. So, look, just like linear permutation. So, considering 3 members, secretary, assistant secretary and president as a single entity, as a single one. Total members equals to 15 minus 3 plus 1. So 13. So they can be arranged in a circle factorial n minus 1 equals to factorial 12 ways. Now, president is at the middle here, but S and S can interchange their position. Now, secretary and assistant secretary can interchange their position. Interchange their position in factorial 2 ways. So look, they are together, but president is at the middle. So you do not write, they can be arranged in factorial 3. P is fixed, so these two positions can be interchanged. So therefore, by APC, total number of arrangements. Factorial 12 into factorial 2. So this will be our final answer. Factorial 12 into factorial 2. Now finally, we consider one more problem. A person invites a group of 10 friends at a dinner party and arrange their seat into round tables. A. 5 on round table and 5 more on another. 4 on round table and 6 more on another. Find number of arrangements in each case. So 2 round table. So this is questions of selection at first. First we have to select 10 persons, 10 friends. Then we have to arrange. So look, total friend 10. So if you consider A, total friend 10. So number of selections out of 10, first one, 10C5. So, in first one, 10C5. So, remaining is, if we already use 5, remaining is 5. So, 5C5. So, this is number of selection. Out of 10, 5 can be selected in 10C5. So, already 5 is selected. So, remaining percent 5. So, 5C5. Now, 5 facts in round table 1 can be arranging. So, number of selections, number of arrangements. Number of arrangements equals to number of selection, then number of arrangements. This is factorial 4. 5 persons and here also 5. Factorial 4. So, this is number of arrangements. So, number of arrangements include selections, then arrange. What is the selection? 10C5 into 5C5. Here there is no restriction. 5 on this round table. So, factorial n minus 1. Factorial 4 into factorial 2. And for the second one, number of arrangements, we write the answer, final answer. So, selection 10C4 into 6C6, remaining 6. So, 4, this is factorial 3, 4 minus 1, this is 6, factorial 5. So, this is number of arrangements into round table. So, this is simple problem, but you remember you have to select the person at the beginning. So, today through this video I have discussed about circular arrangements and I have solved 5 problems of circular arrangements. These problems are important for solving problem of probability. Thank you for today.